We are coming now to another important system, which is ADAS ID, and I have here Simon with me, and I'm curious what's new for ADAS IT in this release.
Thanks for having me, Oliver. We have, for our two tools, new features. First, I want to speak about Scenario Designer. The first biggest new feature is the support for the new standard OpenSCENARIO XML 1.3. The standard was released in March this year, and now 2 months later, we already have the support in our tool. And this can be possible because we are working directly in the ASAM standardization group. This means we can already start implementing the new standard features while the standard is still in the shaping process.
So this is the scenario designer and focusing here on the definition. Also, I learned that there is something new then on visualization of scenarios. What do you have here news for our users?
Exactly. I brought a little video that we can have a look at it. The new feature is that we support the icons for traffic signs of different countries. So this can be specialized in the road network file, in the OpenDrive file. And based on how it is specified there with the revision, the type, the country, and so on, we can now find your icons. If you place them in the right folder with the right file names, we find them and we show them in the tool. And the big value of this is that now as a user, I see the right traffic signs as icons in the tool, and I can start specifying scenarios where the drivers, the traffic vehicles, interactively react on different traffic rules. One example would be if you have, for example, a speed limit sign. Of course, a vehicle in front of you would reduce the speed. And now if your ego vehicle is equipped with an adaptive cruise control system, the speed also needs to be reduced and adapted to the preceding vehicle.
So this makes improves the usability and get a better understanding how the scenario looks like and what is then really stored in the scenario files at the end.
Exactly.
Yeah, I also learned that we have not only scenario design and definition and also scenario checks, but that we are able now also to simulate scenarios. What is new here?
Exactly. That's my biggest news. We have a new tool in our tool family, the AVL Scenario Simulator. And this tool is dedicated for closed loop testing of ADAS AD systems. And if we want to look in the tool landscape of tools that all can do this, of course, the market has a lot of tools here. We try to focus on a very specific side, on the high performance execution, which is scalable. So the main difference usually between the tools is that you can choose if you want to have a physical sensor simulation or if you want to run on an object level. And you need this physical sensor-based simulation only if you want to test your perception systems. And these simulation models, if you want to do it right, they need a lot of computation resources. They also need GPUs. And to get one vehicle with 30 sensors running in real time, you need actually more than one GPU. You need the whole set. This means it's quite expensive to scale this. And we focus here on the left side. Our models run in an object-based environment, which is perfect for testing of your planning and controls algorithms. And the models all only need CPU resources. This means they are way cheaper to scale, also in big cloud environments.
Okay. So the engineers who most benefit from are the engineers who are doing the control function development, the calibration of the control functions to the individual vehicle to have real scaled testing on a large amount of scenarios, these repeating tests, if I understand correctly.
Exactly. There are different use cases. You mentioned some. If we start in the beginning, the development teams, they need continuous testing. Every code change needs to be tested, and you need to know, is my software performing better than the previous version? Then you have the calibration, where you can either do this live online on the models, but here our scaled solution allows again to, instead of doing a live online calibration, you can also use optimization algorithms and use design of experience or active optimization algorithms to really do in parallel many different calibration sets to find the best one. And then the final thing is the validation. Also here our tool can support. This is then really if you say your software is mature now, you need to do this final quality assurance validation, which is usually part of the SOTIF methodology. Here you can use again our tool to sweep huge parameter spaces to really find the unknown scenarios you haven't tested before.
Sounds great. How does this now really look like, this scenario simulator, that we get an impression how it looks like?
I have again a video for you. We see it here. First, you configure your model. We offer flexible models for sensors and vehicle dynamics, but also interfaces to include your third-party tools. And then the simulation directly happens in parallel. So you see here, I started a run with, I think, 120 cases, and there are already 12 running in parallel. And we do a live KPI evaluation, showing you, was this test now successful or failed? And you can implement your own evaluation metrics here. And you can also define what are the acceptance criteria so that it would be marked as passed in green or failed in red. Mm-hmm. And then, of course, if you have specific cases that failed and you want to understand what went wrong, you can jump in the detail view and do a replay of the simulation results. This is in 3D, as you can see here. You also see, of course, some scalar data on the side, which help you to find interesting parts in the simulation runtime. You can look at the situation from different sides. You can go forward, backward in time, and see what exactly went wrong. And in this situation that we have here, we see this could have been a side crash, but our vehicle actually doesn't really detect this target vehicle.
I understood that you showed here the cases which were simulated, which was just a limited number, but if I understood correctly, in a real case, this would be thousands of cases which you are simulating and you are able to run them in parallel. What about parallelization here? Are there limitations, or what does it mean for the user to do things in sequence or to be able to parallelize?
Our tool is always focused that you can run in parallel. So this is really given, even this, what we saw, this was on a notebook. And here I could do already 12 simulations in parallel. And we saw here only one logical scenario where we did the parameter variation, which then ended up in 120 concrete cases. In the end, of course, this is open to each custom use case. If you want to make hundreds or thousands of tests, usually also this would be recurring. And if you want to scale this up, like I mentioned, this was now on a notebook. If you go on a bigger workstation, you can already achieve a throughput of, let's say, 10,000 scenarios per hour, which is quite a lot per day if you multiply this. And then you can also, if this is not enough anymore, you can really go into a cloud environment where we run the simulation containerized in Docker containers on a Kubernetes infrastructure. And there you can scale as much as you want or as much as your budget allows.
We have seen also at the beginning the model setup. We saw the different elements with control functions, with vehicle, with environment. Is it possible to replace here components if I say I have my own vehicle model, or I have other components where I want to bring in? How is it with respect to flexibility?
This is a very good question. Actually, this is one of the main highlights of the tool. So as I mentioned, our tool comes already with a simple object-based models, but the main idea is that the tool is completely modular and open and flexible. So you can replace models either with different models as functional mockup units, which is a standardized simulation exchange format, but you can also use our open interfaces to couple any kind of third-party tool that you want to run in a co-simulation. And of course, we need these open interfaces also to integrate the actual ADAS software. So ADAS software can be compiled in different formats and shipped in different formats. So here we also need to be flexible. Not always a virtual ECU is not always compiled as an FMU. For example, we also support ROS1 and ROS2, but in the end, also with our custom interfaces, you can integrate whatever you want.
That's impressive. Scenario Simulator, brand new. how can the user learn more about it and how can they access it?
Of course, I invite everybody to check the website for more details. And there's actually another highlight that I want to mention. There will be a free version of the tool. So besides our premium version that offers premium features and access to our support experts, there will be a free version that everybody can request on our website. And then you can download and try it and really make a picture for yourself if this tool adds value for you. And also, if you want to learn more, there will be a dedicated launch event in May 29th. This is, again, you can find this on the website, how to participate, how to join.
Thanks a lot. I'm curious then to see how the user give us feedback, and with that, we move on.
Thank you.